Geometry, this is the last section of Chapter 11. What a short and sweet chapter this is. We're talking about spheres today. Please pause the video and come back when you're ready to check your... And here you go. You might pause the video and check and make sure your answers are accurate. Today's objectives are to learn and apply the formula for the volume of a sphere and learn and apply the formula for the surface area of a sphere. Our vocabulary today is, for the most part, not new to you. I think there is one term that's new, the final term in our list, great circle. So the locus of points in space that are a fixed distance from a given point called the center of a sphere, that whole set of points is a sphere, right? What connects the center of the sphere to any point on the sphere? Center to any point on the sphere would be the radius of a sphere. And then we have half a sphere, so in this image we have this green kind of solid half over here. That's called a hemisphere, right? Yeah, the Earth, we say, has a northern hemisphere and a southern hemisphere, right? And then here it is, the super new word, the great circle. The great circle is the dividing line of the two hemispheres. So it's like the equator. Excellent. The great circle. We could call it, instead of the equator, we can call it the great circle. And this figure here shows a hemisphere and a cylinder with a cone removed from the interior. So the cross sections have the same area at every level. So the volumes are equal by Cavaliere's principle. We will prove that the cross sections have equal areas in an exercise that we will do. So the height of a hemisphere is equal to the radius. That makes sense, right? Imagine that this was an entire sphere. The height is from the center point to a point on the sphere, which is equal to a radius, right? So this is showing you that the volume of a hemisphere is equal to the volume of a cylinder that is the same height as a hemisphere, right? And minus, the volume of a cone that is that same height and radius as well. So we can write this as the volume of the hemisphere is the volume of the cylinder minus the volume of the cone. When we think about volume of cylinders, we know it's base area times height, pi r squared times height. Volume of a cone is a third of that, right? 1/3 of pi r squared times height. So when we simplify this, we end up with 2/3 pi r squared times height. And the height of a cone in this case, or the cylinder, is also a radius. Those two things are equivalent, right? So we can actually combine that, or call that r, and we now have 2/3 pi r cubed. This is a hemisphere, 2/3 pi r cubed. So the volume of a sphere, with that radius r, would be 2 of these, 2 times these, right? And when we multiply this 2/3 pi r cubed by 2, we get 4/3 pi r cubed, which we have used before. We used way back in pre-algebra. We said that the volume of a ball, a sphere, is pi r cubed. It's 3 dimensions, so r cubed, and it's 1 1/3 of pi r cubed. So 4/3 pi r cubed. That's how we can derive it. So again, the volume of a sphere with a radius r is 4/3 pi r cubed. So let's find the volume of a sphere. Start with your formula every time. Substitute your known values, and away you go. Pause your video, come back and check. So if we have a diameter of 24, we have a radius of 12. And the answer is left in terms of pi, rather than in a decimal answer. Find the diameter of a sphere that has a volume of 36,000 pi centimeters cubed. Once again, start with your formula. And now we're going to substitute the known volume. And there we go. We can now use our inverse properties of equality. Divide pi from both sides, multiply both sides by 3/4, and r cubed is 27,000. So how do we find r? That's right, we take the third root, cubed root, and we have a radius of 30. If the radius is 30, the question asks for diameter, so diameter is 60 centimeters. Find the volume of this hemisphere. Come back when you have it. Okay, so you should have started with your formula. If you recall, a sphere is 4/3 pi r cubed, so a hemisphere is 2/3 pi r cubed. And now we substitute our 15, and when we simplify, we have 2,250 pi meters cubed. Ooh, interesting. A hummingbird eyeball has a diameter of approximately 0.6 centimeters. So how many times as great is the volume of a human eyeball as the volume of a hummingbird eyeball? We definitely don't have enough information. We need to know something about the human eyeball, right? So let's see. If we knew, let's see what they tell us. The hummingbird eyeball, we can actually find the volume using this diameter. We'll have to find the radius, right, of this hummingbird eyeball, and that would be 0.6/2 or 0.5. I'm sorry, 0.3. And then here's the unknown bit of information that we would have to get from the text. So you didn't have that information. But once we know that the hummingbird eyeball is this small in volume, this tiny thing, we would say 0.11310 times x, times what? X equals this human eyeball. And when you divide both sides, you would find that x equals about 72.3 times as great in volume as the hummingbird eyeball. Recall the surface area of a sphere. Remember that baseball that I took apart and showed you all in pre-algebra? When you pull that baseball apart and lay it out flat, it looks like about how many circles make up the surface area of a sphere? That's right, 4 circles. So the formula is surface area equals 4 pi r squared. So find the surface area of a sphere with a diameter of 76 centimeters and leave your answer in terms of pi. Pause the video, come back, show your work. Once again, we start with the formula. Substitute our radius, so you're going to have to divide your diameter by 2. And we have 5,776 pi centimeters squared. Find the volume of a sphere that has this surface area. So we're asked to find the volume. What do we need to find volume? Radius, right? So we're going to have to use this surface area to find radius. So let's start with a formula for surface area of a sphere. Surface area of a sphere equals 4 pi r squared, right? Now we put our known surface area, substitute. Isolate r squared, take the square root, and your radius is 9. Now we can use that known radius in the volume formula for sphere. So we start with that formula. Volume equals 4/3 pi r cubed. And pause the video if you haven't found it. Come back when you're ready. You should have found 972 pi inches squared. Find the surface area of a sphere with a great circle that has an area of 49 pi miles squared. Find the surface area of a sphere with a great circle that has an area, the great circle itself has an area of 49 pi. So if that circle has an area of 49 pi, can we find the radius of the sphere? The radius of the sphere would be the radius of the great circle, wouldn't it? So we are going to say area of a circle equals pi r squared, and we'll plug in our known area, 49 pi. We'll divide pi's away, and r squared is 49, so what is r? 7. Good. And now we're asked to find the surface area of this big sphere. And the surface area of a sphere equals how many circles? 4. 4 pi r squared. And we can go back and use our known radius. And we have 196 pi miles squared. Big surface area. Okay. The radius of a sphere is divided by 3. So how does that affect the surface area? Do you remember how a factor affects a linear factor like radius affects an area? I bet you do. So the original dimensions for the area would be 36 pi. When we divide the radius by 3, we end up with a very small one, right? A very small radius of 1, and we end up with 4 pi. 4 pi meters cubed versus, this is actually should be squared, right? These meters should be squared. Once again, the textbook has placed a unit that doesn't make sense here. We're talking surface area, so our units should be squared. I think the numbers themselves are correct. 36 pi meters squared and 4 pi meters squared. So how did dividing the radius by 3 impact the surface area? By a factor of 9, right? We ended up dividing by 3 squared. So it's an area problem, so the factor itself is squared. Okay, we have a composite figure now. Fun, fun, fun. And you find the surface area and volume of this composite figure. Give your answer in terms of pi. Well, to find the surface area, we make a plan, right? We have a hemisphere without its base, right? So half of a sphere. And we have a cylinder without one of the bases. So we make that plan. Let's see. So the hemisphere is half of pi r squared, 4 pi r squared, which means 2 circles, right, instead of 4. And we can substitute our radius of 6 squared, and we have 72 pi inches squared. The cylinder's surface area is now the lateral piece is the circumference times height, right? And the one base is just the one circle, pi r squared. We're not going to include the base that's interior here. It's not on the surface. So when we add all of these parts together, we have 216 pi inches squared. Finding the volume of this composite figure, again, we begin with the formula for the volume. If we want to start with the hemisphere, then the volume of a sphere would be divided by what? That's right, by 2, or multiplied by 1/2. So we have the volume of the hemisphere. Now we need the volume of a cylinder. And again, that is base area times height. There it is, base area times height. When we add these up, we have a total composite volume of 468 pi inches cubed. Have fun.